Hi there, this is the review for the final exam, and I am the amazing Mr. Jansen. So away we go. If I look at this first one, I'm just using my properties of exponents here, or my rules of exponents. And I'm going to follow order of operations. I start inside the parentheses, so I do the 16 divided by the negative 8 is a negative 2. When I divide, I subtract the exponents, so 3 minus a negative 5 is going to be x to the 8th. That'll give me a y to the 5th and a z to the negative 7th. And just be careful with your signs there as you're subtracting those exponents. And now I'm going to raise everything to the 4th power. Negative 2 to the 4th power is 16. I multiply the exponents. And then the last thing I do here is I take care of negative exponents. Remember, I send those to the denominator. So it's all over z to the 28th, and that's it. Okay, so I start inside the parentheses. I do my division. Then I raise everything to the 4th power, so I'm just following order of operations. And after I'm done with all of that, then I go ahead and take care of those negative exponents. Okay? If I take a look at the next one, number 2, I've got the square root here, so I'm looking for perfect squares. And so when I see this thing, the 288 breaks down into 144 times 2. The x to the 5th I can break down into x to the 4th times x. And the y to the 10th is already a perfect square because it's got an exponent that's divisible by 2. And now I take the square root of each of these perfect squares. The square root of the 144 gives me a 12. The square root of x to the 4th is x squared. The square root of y to the 10th is y to the 5th. And I'm still left with a 2 and an x underneath my square root symbol. And that's it. All right? And number 3, it's the cube root. So I'm looking for perfect cubes this time. In terms of numbers, this is going to be a 27 times 3. For the variables, I just need exponents that are divisible by 3, so I'm going to break that down into x cubed times x squared. The y to the 10th, I'll break down into y to the 9th times y. And now I take the cube root. Sorry, I missed my cube root symbol. There we go. So now I take the cube root of each perfect cube. The cube root of 27 is a 3. Cube root of x to the 3rd is an x. Y to the 9th is a y to the 3rd. And then still under my cube root is a 3, an x squared, and a y. And that's it. Number 4, I'm looking for a 5th root this time, so I need perfect fifths that divide evenly into here. For 96, that's going to be a 32 times 3. Now I'm looking for variables that are divisible by 5, which each of these already is. So now I take the 5th root of each perfect fifth. That's going to give me a 2, x, y, and still trapped under the 5th root is that 3. That's it. For the next one, I'm just substituting these values in. So I've got 16 to the negative 1/2 power times, that's going to be a 1/64th to the negative 2/3 power. And the first thing I'm going to do just to clean this up a little bit is I'm going to go ahead and take care of these negatives. Remember, negative exponents just flip this thing. So this is going to give me a 1/16th now to the positive 1/2. That's what the negative portion of the exponent does. It flips whatever's in those parentheses. Same thing here. It's going to flip this guy now to the 2/3 power. And keep in mind when we do this, when you have a rational exponent, the numerator essentially is the exponent. The denominator is the root. So the 1/2 power is the same thing as the square root. And the square root of 1/16 is 1/4. Over here, again, the numerator is the exponent, and the denominator is the root. And I'm going to do this. I'm going to do the root first. It doesn't matter what order we do it in, but I'm basically going to take the cube root of this thing, which is that 3, and the cube root of 64, if I imagine that for a moment. The cube root of 64 is going to equal a 4. So then what I have here is I've got a 4. And now the only thing I have left is that numerator. This numerator being the 2 means I'm going to square this thing, which means I end up in the end with a 16 when it's all said and done. So when I do 2 to the 1/3, or so the 2/3 power, it leaves me with that 16. Okay. And now I just have the 1/4 times 16, which is 4, and that's it. All right, so we're just using those exponents and what we know about our rules of exponents and rational exponents to simplify the expression. In number 6, we want to solve this thing, and the first thing I'm going to do is isolate the radical symbol, so I'm going to subtract the 3 from each side. When I do that, I end up with x minus 3 equals the square root of 4x. And now to undo the square root, I'm going to square each side. Over here, when I have x minus 3 squared, that's like x minus 3 times x minus 3, which I have to multiply out. That's going to be an x squared minus 6x plus 9. And now I have to subtract the 4x from each side. So I find out that x squared minus 10x plus 9 equals 0. And now I build a bridge. I factor this thing and factors into an x minus 1 and an x minus 9. I set each factor equal to 0, and I find out that x equals a 1, and x also equals a 9. And the last thing I might want to do here is plug this back in. I've got to check for extraneous solutions, and really what I can't have here is negatives. So each of these does work. So x equals the 1 and the 9. All right? Taking a look at the next couple, just using my function notation. The first one says f times g of x, which means I'm just going to take my f of x function, which is the x squared plus x minus 5, and multiply it by the g of x function, which is the x plus 4. And now it's simply just using my distributive property. That's going to give me an x cubed plus 4x squared plus x squared plus 4x minus 5x minus 20. And now I'm combining like terms. And that's it. In number 8, it's just telling me to divide these two things. So I'm doing x squared plus x minus 5 divided by the x plus 4. And to do this division, I'm just going to use synthetic division. So I put the negative 4 inside my box. Remember, it's always the opposite of what's down here. It's like I'm testing the solution. Now I write down my coefficients. Keep in mind that if I'm missing any coefficients, I've got to plug a 0 in their place. I don't have any missing values. I've got the squared, the first power, and the 0 power. So I've got 1, 1, and negative 5. So just remember that we need every term in descending order. And if we're missing one, that's when we have to put a 0 in its place. In this case, we weren't, so I wrote down the coefficients. And now I bring down this first coefficient, which is the 1. I multiply what's in the box by what's underneath. That gives me a negative 4. I add straight down. That's a negative 3. I multiply. That gives me a positive 12. I add straight down, and that's a 7. And now since I started with an x squared divided by an x to the first, it means this is going to start with an x to the first. So I have x to the first minus 3 plus a remainder of 7, which I put over the thing I was dividing by. Okay? In number 9, we're asked for the composition here. This is like saying f of g of 25. And really, this is just a chain reaction of substitutions here. So I'm going to plug the 25 into the g function right here. So when I do that, if I take it off to the side, I plug the 25 into this function right here. So that's to the 1/2 power, and 25 to the 1/2 power is a 5. So what I end up with then is f of 5. And that's just telling me to plug a 5 into my f function, which is up here. So I'm going to do 5 to the 3rd power plus 1. So that's a 125 plus 1, which is 126. And that's it. So I'm just substituting one thing into the next thing. For this one, it says g of f of 2. So again, I'm plugging the 2 into the f function. So I'm plugging this into the f function. So I'm starting with the f function this time. That's going to be 2 to the 3rd plus 1, which is 8 plus 1, which is 9. So now what I have here is g of 9 when I substitute that in, which means I'm plugging a 9 into the g function. So I have 9 to the 1/2 power, which is a 3. All right? In the last one, it's just asking me to do f of g of x. In other words, if I plug an x into the g function, it's just going to be x to the 1/2 power. It's already written that way with an x in it. And now I'm going to plug that into the f of x function. So I'm going to have x to the 3rd power plus 1. But instead of x, I'm plugging in this x to the 1/2 power. And now it's just my properties of, or my rules of exponents. I multiply. That's a 3/2. I'm just going to leave it like that. If you want to write that as the cube root of x squared, that would be fine. Or sorry, the square root of x cubed, that would be fine also. Okay? If I look at the next one, it asks me to find the inverse. And remember, this is like saying y equals x squared minus 2. So to find the inverse, I just switch the x and the y values, and I solve for y. So here, if I switch x and y, that's going to be x equals y squared minus 2. And now I'm going to solve this one for y, so I'm going to add the 2 to each side. I end up with x plus 2 equals y squared. And now I take the square root of each side. And I just have to remember, since I took the square root of each side, I have to remember that I do plus or minus that square root. So it's plus or minus the square root of x plus 2. And that is important here because the original function is a parabola. And if I forget the plus or minus, I'm not going to have the entire inverse. The plus or minus gives me an entire sideways parabola as opposed to just half a sideways parabola. Okay, so don't forget that plus or minus when you take the square root of each side of an equation. For this one, again, this is just like saying y equals x to the 1/3 plus 4. The inverse tells me that I need to switch the x and the y, so I do x equals y to the 1/3 plus 4. And I'm just going to solve for y. So I subtract the 4 from each side. To undo the 1/3 power, that's like the cube root, I have to raise each side to the 3rd power. And you can see that when I multiply these exponents, it just leaves me with a y. Over here, I'm just going to go ahead and leave this as x minus 4 to the 3rd power. I'm not going to multiply that out. I'm going to leave it in this factored form. Okay? In the next one, again, this is like y equals 2 plus the natural log of x. I'm going to switch the x and the y, so I'm going to rewrite this as x equals 2 plus the natural log of y. And now I'm just going to solve for y again, so I'm going to subtract the 2 from each side. So I end up with x minus 2 equals the natural log of y. And to undo the natural log, remember, any logarithm I have, if I have log base 2, I do 2 raised to the power of each side, where each side of the equation becomes my exponent. This is natural log, so I have to do e raised to the power of each side. So I do e raised to the x minus 2 equals e to the natural log of y. And the natural log and e cancel each other out. So I find out that y equals e to the x minus 2. And that's it. If I take a look at the next couple, I'm going to graph each of these, just drawing a quick sketch so I can get my domain and range. So when I look at this, I should immediately recognize that this square root function is going to give me half a sideways parabola. My typical function would look like this. But since I have a negative inside where x is, it's going to flip it over the y-axis here. It's going to flip it horizontally. So it's going to look something like that. And so now I take this and I identify my domain and range. The domain, the x values are all less than or equal to 0. And the range, I can see all the y values are greater than or equal to 0 because it goes up. And that's it. For the next one, this is just like the previous one, except I have a couple more shifts. Remember, the original function looks like this. Inside with the x, I'm subtracting 3, so that's going to move me to the right 3. So that would put me here. And then I'm going to move down 1, which is going to put me here for the start of my parabola, or half a sideways parabola. But instead of opening up, this one's going to open down because of the negative symbol. So it's going to look like this. Okay? And again, it's still that same shape, but it's been moved around a little bit. And now I can identify my domain and range. My domain is x is greater than or equal to 3. And my range is y is less than or equal to the negative 1. Okay? If I take a look at the next one, again, the original function, the parent function, would look like this. It's that twisted parabola. That's what x to the third functions look like. But this is negative, which means I'm going to flip it, which means this part that was going down is now going to go up, and the part that was going up is now going to go down, so it's going to look like this. That doesn't really affect my domain and range. As I look at this thing, the domain here is still all real numbers. The range is also all real numbers. Okay, so my domain and range for that one, all real numbers.